Oh my gosh, a cliff problem, right? Okay, so let's see, we've got horizontal and vertical and X, VI, VF, A, and T, X, VI, VF, A, and T. Okay, so it's a 15-meter tall cliff, right? So here's this cliff. And he lands 12.4 meters from the base, right? So that, I think, is our horizontal X is 12.4, right? Our vertical X is down 15 meters, right? It's a purely horizontal velocity, so this means this is 0. This is negative 9.8. This is 0. That makes these guys the same. Whatever they are, right? Okay. And I'm going to do, the first thing I'm going to do is I'm going to find the final velocity, right? So I'm going to use VF squared, VI squared plus 2AX. So VF squared is equal to 0 squared. And this is 0 because it has a purely horizontal velocity, so there's no vertical velocity. Plus 2 times negative 9.8 times negative 15. So the absolute value of VF is the square root of 2 times 9.8 times 15. 17.146, right? But we're going to say it's negative 17.146 because it's going down, right? The vertical velocity would be negative. So we choose 17.146 negative meters per second as our answer. All right, and then let's figure out the time it takes to hit the ground. I'm going to use this guy. So negative 15 is equal to 0 plus 1/2 negative 9.8 times t squared. This is the one that people really struggle with. So let me take you through the math step by step. First step is multiply both sides by 2. Right, the 0 goes away, right? And that's going to equal negative 9.8 times t squared, right? Okay, the next step is to divide by negative 9.8. That gets rid of that, right? So 2 times negative 15 divided by negative 9.8 is equal to 3.06. And then that equals t squared, right? So I'm going to square root both sides, right? And I get 1.7496. Right, so we've got the time. We don't have the horizontal velocity yet. We're going to get that, right? And then the time goes across, right? So 1.7496. Now we can find the velocity, right? So v is x over t. So it's going to be v is 12.4 divided by 1.7496. I'm getting 7.087. And that is there's only one horizontal velocity. It stays constant, right? So we've got that, right? And then draw a picture of its final velocity of impact. So remember these two velocities, the 7 point whatever and the 17.14 whatever, okay? Remember this guy and this guy. And I'll show you how to draw that picture, but I need to erase this, okay? Are you ready? I'm going to erase. Here we go. Boom. All right. So the velocity of impact is over 7.087 and down 17.146. Be sure you draw this as an arrow. Make sure you label which angle you're going to find. So that angle right there is tan minus 1 of 17.146. Over 7.087. We fully expect this to be bigger than 45 degrees because of the way I've drawn this, right? So second tan of that guy divided by this guy. 67.5 degrees. So label this guy 67.5 degrees, right? And then the speed it's traveling, that's just the hypotenuse of this guy, right? So 7.087 squared plus 17.146 squared. So square root of, now I'm using the unrounded values in my calculator. 18.6, 18.55 meters per second, or 18.6, right? So we did get these answers, right? So this is 18.6. Yeah.